My name's Robyn Taylor, and in this series, I'm going to show you some of the die making tools, how to use them, and how they're designed to save you time while maintaining quality. So in this first section, we're going to prepare the one-up. Artios contains all the tools you'll need to optimize the one-up and so that you can save time later in manufacturing. And I'm going to show you some of those today. So the first thing I'm going to do is save down the file, and I can use the auto number, but in this case, I'm going to just save a new version number using a suffix. The preflight tool helps us to identify over 50 different parameters, which we can adjust according to our own preferences. This acts as a kind of checklist, so you don't have to keep memorizing the same routine checks. There's a visual indication in the design window, and on the right-hand side, there's a list of checks, errors, and warnings, which you can click through and review. The first one I'm going to show you here is the merge short lines, and you can see the radius is broken into two sections, and we can optimize it by creating one single radius. Because there's a blue spanner, we can click and fix all the errors in one go. The next warning here is that there's a gap in the layout. Now it's showing me a preview of what the imposition would look like, and I can see here that a small gap which is too difficult to rule. So by making a quick adjustment to the dust flap, I can give myself more flexibility in the design and allow a single knife die. So I've optimized the design without having to go into the layout. The next issue here is there's a bridge near an intersection, which isn't ideal. So first I'm going to turn my bridges on so I can see them in the view mode, and I can then see what I need to adjust. And firstly, so these apertures don't drop out, I'm just going to add some more bridges here on this straight part, and then delete the offending bridges. Okay, so I've refreshed, and now you can see there's no anomalies in the design, and we're ready for manufacturing. The next thing I wanted to show you here is the cutback crease tool. What we can do here is cut back the creases from apertures, for example, without affecting the laser path. This gives us a little bit more flexibility with our outputs. So for example, we can send the full path for the laser, and we can still have our counter matrix working as we expect it to. So the last thing I wanted to do here was create a glue assist perf. So using a custom hatch pattern, and click once and it's created the array for me. So you may notice a couple of tiny rules appeared. So I can use the design fix it to identify and solve these without having to go and manually do that. So I can click and select the one if I want to, or just fix all. And it's now ready for ruling. So there you have it. The one-up design's ready for manufacturing, and in a few clicks we've identified issues, solved the problem, and saved time for the layout later. So the next step is creating the counter plate. So I'm going to start with a Pertinax or phenolic style counter plate, and I'm going to do this in the one-up. I'm just going to turn on the counter matrix tools, and I've also created a custom toolbar which includes a geometry macro for the laser positioning guides. There's a number of different shapes for the positioning holes, and I like the three-sided one, so that's what I'm going to go with. So I'm going to place those sensibly across the design within the panels using the auto positioning guides, which I can snap to, and then we're ready to go. So the next thing we're going to do is run the counter wizard, and all of the parameters are fully configurable, and you may have different preferences for different customers, for example, and we can save those in the machine parameters within the defaults. And there's a number of different parameters which can adjust our plotting path for the router. So in one click, I've created my complete path with my positioning guides, and then all I've got to do is add a name, for example, the file name in this case, and we're ready to go. So I can send this one up straight to the router, or I might want to create a layout for the material size we have. So I can use the counter layout tool to step and repeat as you would normally. And now our full path is ready to send to the plotter or the router. So there, in a few ticks, we've created our one-up counters, applied our laser positioning holes, and we've sent it to the plotter ready to plot. Now, one of the other things we might want to do is create a steel counter. So I'm just going to create a quick layout, in this case 6 up, and add a Dieboard, and run the steel counter tool. So you can see it's created the full path with all of the channels, the outside edge, any positioning holes, and a name etched into the design. Now we might want to send that to the router also, so we can send the output in two different ways, either as the full path, or you can send as single lines if you have a different cutting tool for each channel width, and obviously that will run a lot quicker. So in a few clicks, we've created a single one-up counter or a full steel plate ready for manufacture and customized to your needs. In this next section, I'm going to create the layout and build the dieboard. When we're designing a layout, what's important is optimizing the material, reducing the amount of waste, and making sure that the design goes through the press as quickly as possible. So ArtiosCAD includes all the tools that can help us do this. The first thing I'm going to do is run a standard sheet layout, which means I can optimize my material usage and make sure I'm using the best layout for the design. So you can adjust some of the parameters, choose a material that suits our design, press OK, and by sorting on the waste, I can see that a 6-up layout with around 40% waste is the most optimum design here. The next thing, it's going to ask me what machine I'm going to use, and this could be a different press within your factory, or it could be a different customer preference. All the preferences are saved in the default related to these machine parameters. So you can see it's adjusted the grip edge here. I'm going to shrink my sheet down and add my dieboard. When building a complex layout, there's many repetitive tasks. So by optimizing our preferences, we can reduce the amount of clicks and get to our design quicker. For example, I can add my dieboard, add some handholds, add a burn name, for example, or by changing the die press here, I can use a custom toolset, meaning that all my settings are saved so that I can click once. I can have a complex dieboard layout ready to go in a single click. The next thing I'm going to do is bring in my bolt hole pattern. I'm going to select the holes that are viable and press OK, and then the rest will be gone. Now, if you have an oversized design, you may want to put a split into the tool. Doesn't make sense for this design, but I'll show you an example. So we can add a split horizontally and vertically, so the design will be set as we expect. What I can also do is apply a custom pattern using a geometry macro, so that in this example I have a dovetail, and it's ready to go in a couple of clicks. So that's our next stage complete. We've optimized the design for our material usage, applied a dieboard in a couple of clicks, and we now have a layout ready to go to the next stage. So in this next section, I'm going to show you some specific tools for rotary dies, again designed to optimize our workflow and make sure we're designing in a few clicks and saving time in production. So I'm going to create a quick layout here, and I've selected the rotary die press parameter set, optimize my sheet, and now I'm just going to add in a dieboard. Now, because it knows that the design is bigger than 33 inches or 840 millimeters, it's going to put a die split in the design. Now I'm just going to move that to somewhere sensible and so it's not crossing a complex path. And we now have our die split in the right place, ready to go. So the first thing I want to do is apply a bolt hole pattern, and I want to make sure the die is held stably on the press. So I'm going to select horizontally and then vertically to make sure I have enough holes in central places across the die. You can see that it applies a visual check to make sure there's no dead areas and that I have a die that's going to be fixed securely to the press. So the next thing I'm going to do is apply my scrap knives based on a predefined pattern, and I can adjust this on the fly if I want to, or I can just use my default parameters and click once and it's created. Now, as you can see, it now interferes with some of those bolt holes. So I can adjust the pattern horizontally and vertically to get as many holes as possible, and then rerun the tool and it will delete those that aren't now viable. So the next thing I'm going to do is apply some waste numbers. So for example, if I want to identify an area that isn't cutting correctly, I can do this by auto-numbering. I can click through into a position, or I can auto-number and identify the shapes in the waste, which I can use on the press. Finally, I'm going to apply my rubbering. And again, there's a range of settings based on my machine parameters, which I can adjust manually, or I can apply all, and it creates the rubber shapes as I need them to be. Or I can use some of the specific tools to create a manual layout. And the last thing is I might want to apply a plastic sheet, which I can do as a full sheet with the holes removed, or I can apply just the waste areas ready for manufacture in a single click. So that's a quick overview of some of the Rotary manufacturing tools, which we can use to optimize our design, reduce the amount of clicks, and save time in manufacture. Stripping boards can be complex, but if they're designed well, they can save a lot of time manufacturing. So ArtiosCAD provides all the tools for creating stripping boards quickly and efficiently and optimized around your machine parameters. So the first thing I'm going to do is add my mounting bars, and that's going to apply a stripping knife so that we can see the starting point for our external waste. So the next thing I'm going to do is just apply some stripping knives in these dust flap areas so that I can remove this waste here. So as you can see, toggling the repeat tool means that I only have to draw it once and it repeats it across the layout, saving me time in the design. The next thing, I'm going to apply some carrier rolls just to break at this waste and again allow my sheet to pass quickly through the press. All the tools in ArtiosCAD allow us to adjust our parameters for each machine, and so that in a few clicks we can create a complex layout. And the stripping tool is no different. So each time I click into an area, it's drawing the related upper and lower pattern and also applying any pins, blocks or pushers that needs to. Or I can recalculate all and it will create all the paths. So in a single click, I have a full stripping board pattern ready to go. So looking at this design, I can see it's suitable for a full-out strip. So I'm going to remove these exterior knives, and by recalculating all, I can rebuild as a full-out strip, and the design is ready to go with all the pins, pushes and knives that I might need. If I want to further customize by adding additional hardware, I can do. For example, I can add in some interference here by clicking into the waste areas, and it will repeat across the design. Next, I'm going to add in some breathing holes so the sheet doesn't lift. As I look at this mounting bar here, it's not ideal. I probably want to move it down out of the way, but I don't want to have to redesign the whole thing. So I can just go in, delete the extra stripping knives and the bracket, reposition and recalculate all, and I haven't had to rebuild the whole design. Now the next thing I might want to do is add in a front waste separator, again, which I can do in a single click based on my machine parameters, or I can adjust manually if I want to. As with all the board sizes, you can right-click and adjust the properties. So for example, if you want to change the dimensions, you can do, and it will recalculate the path for you. So as you can see, in ArtiosCAD, we've created a full set of stripping boards ready to send to your laser or pin setter, fully customized to your customer or die press parameter set, ready to go in a few clicks to save time in manufacturing and optimize to your workflow. So the next thing I'm going to talk about is nicking and rubbering. As with all the tools in ArtiosCAD, they're fully customizable based on your machine preferences. So firstly, it asks if I want to optimize the raw path, which I'm going to do. So I'm going to click all my horizontal lines, adjust the frequency and spacing, and then apply. Then I might want to have a different spec on the vertical, so I can click through, adjust this pattern, and do the same. So we can adjust the view mode in our defaults. So we may want to have the nicks centrally across the line, for example. So you may want to send it to your raw bender or slotter, or you might want to apply the mark on the Dieboard in the laser path. As with all our other tools, the rubbering can be applied in a couple of clicks based on the machine parameters. So we can review the settings manually and adjust the different profile types or different rubber patterns. We can click into each area that we'd like rubbered, and it will apply the profile suitable for that space. Or we can click recalculate all, and it will apply all of the rubber across the whole tool. So in a single click, we can have all of our rubbering applied based on our machine parameters. We can create an optimized layout in a single click, which can be sent straight to the waterjet or the plotter. Then we can send to our output. So as you can see, each part is numbered, so we can identify which piece goes where. Then we can create a positioning pattern for the assembly team. So in a few clicks, we've created our nicking spec and applied rubbering, along with a layout ready to be sent to our manufacturing. In this final section, we're going to talk about blanking units. ArtiosCAD has a full set of world-class tools required for making blanking units, including all the hardware you might need and BSI-compatible components. So by adjusting the settings for each of our components, we can have full control over the quality checks required and so the operators can work effectively. So when I run the blanking tool, it's going to choose the best components based on my machine parameters, or I can manually adjust the settings and choose whether or not to include a certain component and which type of frame I'm going to use, for example, a combo, grid, or flat tool. So if I recalculate all, in one click, all of the components, the frame, the top and bottom boards, and the pushers are all created automatically for me. So in a single click, we have a complete tooling set ready to go, saving time, but also working within your quality control parameters. Moving on, we might want to add a couple more extra components. So, for example, I'm going to position the non-stop swords to make sure nothing's going to interfere. And I'm just going to place them sensibly across the sheet. Next, I'm going to apply the photo cell to make sure I've got a clear line of sight. If I want to create a full steel grid, I can do. In this case, I'm going to do a simple horizontal line, but I could follow the path of the dust flaps, for example, so that we can send the grid to the BSI. Next, I'm going to add some joggers in. Again, I can select from a wide list of existing designs, but I can also customize my own. And then finally, I'm going to place any hardware, for example, some mounting brackets, which I'm just going to place at the end of this steel rule. So, we've now created our full Dieboard set in ArtiosCAD. All the tools I've shown you in this series are included in the Essentials level of ArtiosCAD when bought as a subscription, all designed to optimize your workflow, maintain quality, and save you time.